This experiment is called the quantum eraser. What they did is they shot out electrons into two different slots of slits. Okay? The particles that go into these slits are detected by these detectors on top of each slit. That way they could count how many particles go through each slit and which path they took. Now what happens was the particles, it is split right here, and right here you have particle A goes to slit number 1. Once it's detected by detector number 1, the particle goes through, comes out, and registers at the screen. Now, the difference between particle 1 and 2, the path they took was completely different. As you'll see, as you can see here, you have the particle B. Particle B took a different route. Particle B was split, goes towards slit number 2. It was detected, it was accounted for, it was recorded, and then when it came out, instead of going towards the screen and registering right here, it took a different path. Instead it came out here and it went into this device, the eraser. And this eraser, basically what it did, it erased the memory of the path that it just took. So therefore, once it was finished being erased, it came back out, and then it communicated with particle A and created an interface pattern. Again, you must realize the significance of all of this. Not only was the memory erased to confirm that the detectors did not influence the results, but also in the process, the delayed process of particle B, in order to have its memory erased, the path that it took was erased. It took a while after this particle already registered. After its memory was erased, here, this delayed process was then, which represents the past, because it took time after this one already registered. The delay process of this particle B was still there was the communication between particle A and particle B still existed and still reoccurred after particle B went through this long process in order to erase its memory, in order to erase the path that it took. And still, this particle communicated with the second particle. It basically told it which path it took after the fact that its memory had already been erased. So you're dealing with 2 or 3 different things occurring at the same time. One, the detectors do not influence the results, because at the end right here, the end results of this path being taken confirms the fact that the detectors themselves did not influence the results, and then the eraser delayed the particle from coming to the screen at the same time as particle A, And then that represents the past because it was delayed. And then somehow the particle A recommunicated the path that it took. And which means that the particle somehow was able to communicate with particle B and tell it what path it took, even after the fact that particle B and its path were erased. Therefore, the past, which is the delay right here, this delay process, and this fact that got erased, this path right here is the delayed past, because it took a path longer than this path. And this one had registered, so this represents the present, and this present affected the past. It communicated even after it was delayed. The particles communicated even after the delayed process of particle B. Therefore, the present of particle A, which registered into the screen a lot sooner than particle B, waited for particle B to arrive after its path and memory was erased, and still was able to communicate to particle B what path it took, and therefore created the end result, which was basically an interface pattern, which is caused by two particles going through two different slits and then interacting with each other, creating a wave. However, if the particle A did not communicate with particle B after the fact, the particle that came through should have registered a particle result here only. There should not have been an interface pattern here if particle A did not communicate with particle B, because this particle had arrived here a lot sooner than particle B. Yet the interface pattern was created because particle A communicated with particle B and basically caused an interface pattern even after the fact that it waited for particle B to arrive. Why didn't particle A create a particle pattern here only, since it arrived there a lot sooner than the particle B? This communication process proves that the present arrival of particle A affected the past delayed process of particle B, and they still communicated with each other. Therefore, there is no time delay at the subatomic level, the quantum level. There's a timeless, non-delayed process for some reason. Something occurs within the subatomic level that allows the particles to communicate in a timeless fashion, as though time did not exist, because this particle still communicated with this particle as though there was no time delay. How on earth did that occur? Do you realize the significance of that?